Okay, we could have a source producing waves that spread out, and we could have a detector here and a detector here. Now, this detector is closer to the source than this one. So as the waves spread out in wave fronts, and we'll say that we're drawing waves at intervals, wave fronts at intervals of, say, 1 wavelength, at a certain point, there will be a wave front that is hitting this detector, okay? But that wave front still has this far to go until it gets to detector 2. So we want to analyze what happens to the phase, the relative phase of the wave between detector 1 and detector 2. And by that I mean, will the wave hit detector 2? When it hits detector 2, will it be in phase with maybe the second following wave, or will it be out of phase? And what will happen if you combine these two signals? Okay, now what I've done here is I've begun sketching a cycle of the wave for every wavefront, and I'm out to here. I'm going to do the same thing from here to here, but I'm going to do it off camera because there's no point in you watching me sketch little tiny waves. Okay, so I've completed all these waves. I don't think I got them just right. I think these are a little closer together than these are, but you understand what I'm saying. They should be the same spacing, and as they move into the detector, the way this worked out, if I enlarge what I see at the detector here, excuse me, the way it turned out in an enlarged view of what goes on at the detector, this wave completes its last cycle just as it's detected, and so does this one. It's detected, let's say, at this point. This one's detected at this point. So they arrive at the detector in phase, so that if we mix these two sounds electronically, let's say we have microphones and we mix them, they're going to reinforce each other. Okay? Now, it could have been that as we approach this detector, if the detector had been half a wavelength further, then the wave would have looked like this. Would have had a valley instead of a peak, followed by a peak instead of a valley, whereas this one might have been, well, this one hasn't been moved, so it's going to come in the same way. If we combine these waves, we see that they cancel. So let me write a statement here off camera. Okay, originally the waves arrived in phase and the combined waves would reinforce. So again, if we wire these up and combine them into one source and listen to the source, we'll hear a reinforced wave. It'll be twice the intensity of either individual wave. Whereas here, if we move detector 2 half a wavelength further from the source, that's going to move the wave half a wave out of phase. The waves will arrive out of phase, peaks will match up with valleys, and the waves will cancel, and we're not going to hear very much at all. So it's not too difficult to understand that the waves will reinforce if the path difference is a whole number of wavelengths. That is, if this path is a whole number of wavelengths greater than this path, then the waves are going to arrive in phase. If you move it half a wavelength more than a whole number of wavelengths, in other words, if the path difference is a whole number of wavelengths plus half a wavelength, then you're going to have cancellation or negative reinforcement. This is positive reinforcement, negative reinforcement, and it goes again as whether your path difference is a whole number or a half number of wavelengths. We can achieve the same thing with two sources. If the two sources are emitting waves in phase, let's say, of the same wavelength, with the same sound in other words, then the distance from source 1 to a listener could well be different than the distance from source 2 to a listener. If path 1 from the source 1 to the listener and path 2 from source 2 to the listener differ by a whole number of wavelengths, then the waves are going to reinforce in the same way they did here. They're going to have a positive reinforcement. If they differ by a whole number plus half a wavelength, then you're going to have this sort of thing where you have this combining with this, and they tend to cancel out.